Hello everyone, my name is Hossein Musavi. I'm presenting this paper on behalf of my colleagues Mariam Khademi, Christina Lopez, Lucy Dodakinian, and Steve Kramer. The title, as you can see, is Haptic Augmented Reality to Monitor Human Arms Stiffness in Rehabilitation. We are from the School of Computer Science and Information Technology at the University of California, Irvine, and School of Medicine, also from the University of California, Irvine. For any correspondences, please feel free to write to the email provided here. Well, the outline of the presentation is as follows. Starting with the introduction, where I talk about stroke, hemiplegia, and impedance, followed by related work, where I talk about impedance measurement methods. Then I will introduce the method of this paper, followed by the implementation of the method, and conclusively discussion and conclusion of the presentation. Well, stroke causes hemiplegia. Stroke destroys brain cells, and if a stroke happens in the right hemisphere, the left side of the body will be paralyzed, and vice versa. So hemiplegia means, or hemiparalysis means, one side of the body will be paralyzed due to the happening of a stroke on the other side of the hemisphere. After stroke, people have to undergo physical therapy and rehabilitation, which requires assessment. Usually the assessment methods used traditionally are qualitative and subjective. So many people have been trying to come up with methods leveraging robotic technology to monitor temporal, kinetic, and kinematic variables such as speed, position, velocity, forces, etc. But some people have been interested in understanding the stiffness of the arm or limbs, which shows part of the mechanical property of the system. However, what shows most of the mechanical property of the system is mechanical impedance, which incorporates stiffness, damping, and inertia. Also, there have been many attempts to leverage the concept of smart home and tele-rehab. So instead of the patient going back and forth to the clinic, they can sit at their homes and the healthcare is provided to them via the internet or a remote device that they play with or they interact with, and the data is sent using the internet over the internet to the clinic, and then the healthcare professional, such as the physiotherapist or the doctor, will look into the data and then monitor their progress. So tele-rehab saves time, money, and effort, and it saves patients from visiting the rehabilitation clinics as many times as possible. So apart from that, there have been robotic technology mainly used in clinics, cannot be even used in all clinics because they are very expensive, and they can never be applied to home rehab concept. But anyway, I explained to them because technically they are related to our work. So robotic devices are used to their very best. They are used to measure the impedance or stiffness of the arm, where the subject moves from point A to point B, and the robot perturbs the hand, and it measures the response to the perturbation, so it measures the impedance. In our work, we are combining some rehabilitation concept with augmented reality. So what augmented reality is, it is actually a technique for human-computer interaction where visual information is augmented into reality. Sometimes it is used for games. It can be used for human-computer interaction. Usually, it uses head-mounted displays, or it uses projectors to project those extra visual information, the augmentation, so the so-called augmentation. So in this case, which is, by the way, another work of ours, a projector For example, in the photo here, you can see a projector projects virtual water. So as the subject tilts the mug, the virtual water pours on top of the table, and then in the other photo, the subject points towards those augmented boxes, music boxes, and if his or her pointing is correct, and then those boxes move around, and then they can play music. In the one far to the right, they have to practice this. The subject practices finger pinching and finger flexion and extension as they move towards those augmented circles, and then as soon as they reach for this circle, the circle all move around or they change their colors, etc. So in our project here, we are going to combine haptic information measured using a special uh, device that we have developed, and we are going to combine it with augmented reality. So here is a brief introduction about the device we made. The device consists of a DC motor, an eccentric mass that rotates and creates sinusoidal perturbation to the X and Y direction, and there is an IMU sensor that measures the acceleration. Correlating between force, centrifugal force, and the vibration, we can understand the mechanical impedance, which is one of the most important data of the haptics of the system. So in this figure, you can see what the system is capable of measuring. So these ellipses are impedance data, and then this system is able to measure these impedances. So for more information, please do read the email, read the paper here, use of a portable device for measuring our planar mechanical impedance during motion. So using the device, those elliptical impedances are measured, and in real time, or almost nearly real time, the impedance information are projected or actually augmented on the video feed that the subject sees on the screen. So as you can see here, there is this camera which tracks the position of the subject's hand, which by the way has a color marker on top of the IMU sensor. And then as the subject starts from point A to point B, or start to the end, the mug perturbs the hand of the subject, and it measures the impedance. So the camera tracks the position, and then using a computer vision system and then some computer graphics, those information are obtained, and then they are blended in to the actual scene, so as to see the picture here. In another parallel system or similar system, the augmented reality is a spatial augmented reality where the camera tracks the position, and then a projector projects those information on top of the subject's hand. As you can see here, the impedance ellipse is augmented on top of the subject's hand, and as the subject moves on the table, the impedance data moves and changes accordingly. So here's what the camera sees and measures. This is the position data from several back and forth reaching trial. And here is the position of a single reaching trial and the respected velocity data. As you can see, when the subject starts moving, the velocity is slow, and then it goes to maximum, and then it slows down before it reaches the end or the target. And here you can see these data, as you can see here, can be augmented either using video-based augmented reality or spatial augmented reality in real time. So in conclusion, the device used here is able to measure mechanical impedance of hand during motion. The computer vision combined with the system was able to track and register the position of the hand and orientation of it. And the computer graphics program was developed to augment those haptic data on top of the video data or projection data, and then a spatial augmented reality and a video-based augmented reality were used for that. And finally, this system is intended to work as a platform to develop AR-based video games for people with physical disabilities like stroke. Thank you very much for your attention. Please, if you have any question, feel free to write to